Okay, well, I'm back on the Nakamichi BX300. I did contact the customer. Actually, the customer contacted me because he saw the video I posted. He does subscribe to my channel. And I told him I want to let it sit for a little bit. And it's been a little over a week right now. So I'm going to go ahead and power this thing back up. And I have 2 meters connected at this point. I have 1 meter in the milliamp position, and I have it connected in series with one of the leads to the motor, the positive lead. And I'm using these very short test leads for minimal drop. And then I have the second voltmeter connected to the actual motor terminals, measuring the voltage on the motor. It is in the 60 volt DC range, and this one, like I said, is in the 600 milliamp DC range. So I'm going to power this thing on. I do have a tape in it. I don't have speakers connected at this point or an amplifier. So here we go, power on. And I'm just going to go ahead and hit the play button here and watch the current readings. Let's go ahead and put this in min-max. And then we'll do the same on this one. So they're not displaying minimum or maximum or average. They're just recording it or logging it right now. So I'm going to hit play. And the tape is playing perfectly fine. So let's see what the min-max voltage was. So we have negative 7.16 volts for the load position. And we have 158.7 milliamps. So I'm going to clear that back out. Oh, and I saw a negative 41 milliamps, I believe. We'll put it back in min-max. Same thing on this one. We'll clear it out. And we'll hit stop and see if it stumbles at all. And of course, it works absolutely perfectly. Well, this might be a YouTube short. 101.9 and a negative 133.5. So I wonder if it ran the motor a little bit and then backed it up just a hair. 7.27 and 0. We'll reset that. And we'll try it one more time. And when I say one more, I mean like 10. And working flawlessly. I was hoping that maybe after sitting for about a week, it would exhibit the same symptom as last time, but obviously that's not going to happen. I don't believe it's a dirty mode select switch, because these are the actual switches. There's 3 of them right here. And remember last time on the video, after I press stop, you could actually see the loading motor move slightly. And then if I encouraged it just with a little nudge of a screwdriver, it kept going. So that tells me that it was some kind of mechanical binding and not a switch telling the processor that it was satisfied where it was. So we got 174.7 milliamps in the forward direction, 169.9 in the negative direction. Pretty doggone close to me. And don't even worry about the average. 7.3 and 7.17 volts. So here's a quick overview of the loading motor drive circuitry. So here's the microprocessor. And we have RM forward, RM reverse. That's the real motor. CM forward, CM reverse, which is the cassette loading motor. And notice the bar on top of these, that means it's active low. It pulls these down to make the functions happen. So if it's going to command the loading motor reverse, pin 9 is going to pull low, and it's going to cause these transistors right here to turn on and off alternately. Now I've got 12 volts on this line right here, and it comes out of this regulator. Well, I say 12 volts because that's what's feeding the regulator, but because they're using a Darlington transistor, there's going to be a voltage drop. So I expect to see just over 10 volts right here. So I've got 10 volts right there. So let's just go ahead and say that we've commanded this transistor on right here. It's going to put basically 10 volts on this line minus the voltage drop across this one transistor. So I've got just over 9 volts on this line right here. And alternately, we need to pull this transistor to ground to complete the other half of the circuit. So another 0.7 of a volt drop. So I've got 8 volts, and I'm seeing about 7-ish and a half, so I'm pretty happy with those results. So when this transistor is on right here, conducting the 12 volts to this rail, this transistor has to be on right here, conducting ground to this rail, and vice versa. When this transistor turns on, it's going to conduct the 12 volts to this rail, and then this transistor is going to be turned on to conduct the ground to this rail, and that goes up to the loading motor, these two conductors right there. This is the real motor, almost a carbon copy of the loading motor right here, virtually the same regulator, other than there is a pot right here, which I believe adjusts the amount of torque the real motor would have. And there's probably a setting in here for high torque, low torque, depending on whether it's in the play mode or fast forward rewind. Anyhow, there's a copy of that portion of the schematic if it's helpful for anyone. Other than that, just like the last video, I think this thing's going to go back just as is. It seems to be working perfectly. Actually,